Hi everyone, welcome to this video. This video we're going to talk about Zener Diode as voltage regulators. This time we're going to just look at the positive kind of voltage regulator. We're not looking into negative, but you can probably, you can make a negative voltage regulator with Zener Diode as well. So let's just put that aside now. We are looking at positive. Basic Zener Diode you can have with just a resistor and your Zener, whatever voltage Zener Diode is. And the purpose of the resistor is to limit the current into the Zener Diode. And each Zener Diode needs a minimum amount of current to start regulating the voltage on its basically where it connects to the resistor. And this is good, but it doesn't provide us with any current. That's what most of the time this is fed into another circuit, either be an op amp or a pass element, to increase the current capabilities of this circuit as a voltage regulator. But we are only looking at the voltage regulator. We're not looking at the other purposes of Zener Diode in this video. So over here we have the exact same thing we had over there, but this time we have our pass element to increase the current, basically, so we can power circuit and things like that. We got the same kind of thing again. This time we feeding the Zener Diode with a 500R here, so we get a better much more current capability, so we can run our pass transistor from it. We have a 220 microfarad capacitor on the base to kill any noise, because the resistor will get noisy and the Zener Diode itself will provide noise, so we don't want to feed in that noise into our pass element. So we're going to have a capacitor here to kill the noise and the ripples and things like that, and the output will be the emitter of our pass element. This time I'm using NPN kind of power transistor tip 35C, because I have plenty of them. And the output of the transistor, which is the emitter, we're going to put a 10 microfarad capacitor to kill any noise and ripple and make things more stable. And over here we have another circuit where this one, it has some form of feedback from the output, where this one didn't have any feedback. It was just straight whatever the set voltage of the Zener Diode will be is fed into the base. Here we have the output taken from our pad, on our output pass element, and so it forms kind of a crude way of feedback, and is fed into our first transistor, and then from there into our medium, and then our pass transistor at the very end. Again, we have a capacitor at the end to make things more stable, and we have a capacitor on the base of our where the junction of our Zener Diode is, to slow things down, and any noise that feeds into here is going to get killed, and we're going to have better regulation over here. And then obviously we have our LM317, which everyone should know about. You have V in, we have your set voltage in pin, and then we have our voltage divider here to set the output voltage, and we have a minimum load, because these voltage regulators will require minimum load to function correctly. Usually is either 120R or 220 or 240R, depending on your circuit. And we're going to have again our output capacitor, and we're going to have a capacitor on the adjust pin to kill any noise and ripple over there as well. We're going to look at individual circuits and see their performances, and see what kind of performance they have on the load. And basically this is it. So this is our circuit. We're going to look at this, we're going to look at this, and we have to look at this. We're going to quickly look at this as well. This one obviously won't provide any current, but we're just going to check it out quickly and see what kind of performances do we get over here. So if I move you guys further to this side and quickly bring my circuit here without blowing things up, bring my things over there. I don't know if you can see everything in the shot. There we go. It's just my hard. So these are the circuits. So this is the basic one we had before. This is with just one pass element here. This is where our feedback type is, and this is our lonely LM317 sitting by itself in the corner, and nobody cares about. So these are our tip 35Cs pass transistors. All of these obviously should be on heat sinks, but we're just going to quickly have a look and see. I didn't have space here to put any heat sink, unfortunately, but for the timing, for a quick look, it will do for now. So let me just put everything aside. So, and this is our load. Basically over here is outside the shot, but we don't need to look at the load. And what I'm going to do is I'm going to move the camera so you guys can see the scope. Let's see what the scope is talking about. Quickly move you guys over here. And there's our lonely scope in the corner by itself. There we go, it's visible, you guys can see. Yep, okay, that's fine. So what I'm gonna do is I'm gonna put my transformer on. That thing's blowing up in our heads. Okay, so transformer is on, and let's see what do we get. So our yellow trace, let's get rid of the help. Our yellow trace is the output of our bridge rectifier, because we're going to take a look at, see what kind of ripples do we get. And this one at the moment is not connected to anything, so I'm going to connect it to our first Zener diode. Basically just Zener diode and a resistor. As you can see, we got noise already, and I'm not pulling any current, so whatever current is just I think it's just our probe basically connected. So as soon as we connect the probe, you can see that we got ripple on it already, and it's reporting around 30 millivolt of ripple on the output of just the first stage. So you can see that it's noisy because we don't have any capacitor set on it. Usually you can put a capacitor across the Zener diode to kill any noise that we have. Let's quickly have a look. If I do that, what do we get? So here we go. I've connected a capacitor across it. Nope, still you can see we are getting noise on it because it's very crude circuit and it's not gonna do anything good for us. Okay, so we're gonna get rid of that now. It did kill a better noise, but not that much. Okay, so what we're gonna do is we're gonna move into the next circuit. Okay, we're over here, and let's see what happens if we move to here. I think that noise was just a background noise. Yeah, we can see it's just the background noises. I think it's to do with our transformer being near our circuit. Okay, let's see. So at the moment we got 4.5 volt, 4.76. Obviously there's going to be a voltage drop across our... Whoa, what's happening here now? Let's see. Something, it is not right, and we are getting way too much. Okay, that's better now. Okay, let's see, what do we get here? Nope, something is not right again. Let's see what we get. Okay, that's better now. All right, so let's see. Okay, so we're on the first stage, and we are looking at the first just one pass element at the end, and this is our output of our bridge rectifier. We got no load on it, so it's nice and stable. Okay, let's just go here, 5 volts. Okay, you can see we got a tiny bit of ripple on there, and we got nothing on the output of our first transistor. Okay, let's look at the output of the transistor on the first stage now. You can see we're getting roughly about 30 millivolt of ripple, where the input ripple is around 6 volts. So it's doing a really good job of regulating and killing the ripple. If I stop that now, because my pass transistor is getting really hot. So we had, if I quickly go again, we got 6 volt of ripple going into our Zener diode and our pass transistor, and we're getting about 30 millivolt out, so which is not really, it's not bad, it's still very good with just the lonely Zener diode and one pass transistor. Okay, so now let's look into the second stage. This is where we had a bit of a regulation with the crude way of regulating. Let's just go on the output look. So this is the output of that, and let's see what do we get. We get about 20 millivolt now of ripple on the output of our Zener diode with form of a feedback, and you can see that was better. It performed better than the first transistor we just looked without any feedback. And let's just look at the output of our LM317. Okay, so now we're looking at the output of our LM317. The LM317 is set to around 7.4 volt, and we're going to draw current quickly, see what do we get. And you can see LM317 is reporting around 10 millivolts of ripple. So LM317 is performing really good out of all of them, because obviously LM317's got much better circuitry inside, it's got much better regulation, much better feedback and stuff like that, so it's rock solid compared to the other one. So with 6 volt of ripple going in, LM317 is only giving us around 10 millivolts, so that's really good. And you can see why LM317 and linear voltage regulators are used widely in a lot of circuits, because it has really good regulation on the output. So let's quickly have a look at our circuits again. Let's go here. There we go. Just quickly make sure that everything's fine. There we go. So what did we look at? We looked at this, obviously. This is our base. And we looked at this, and this one provided around, I can just put here, around 30 millivolt of ripple, and this circuit was around 20 millivolt of ripple, and our LM317 was a clear winner with around 10 millivolt of ripple. Okay, now you will say, okay, so what's the point of using these circuits where I have LM317 here? Why do I need to use these circuits? Well, basically where these circuits come into hand is where your input voltage is greater than what LM317 can handle. LM317 can go roughly around 40 volt, 45 volt. There are higher voltage version of the LM317. They're usually marked HV at the end, and they go to around, I think, 60 volt. But anything above that, you won't be able to use LM317 or all the linear voltage regulators that we have now. At the moment, you can't use them on those high voltages. This is where these two circuits shine. Say, for instance, you have a power supply that your circuit needs 100 volt of regulator. So you need to provide 100 volt into your circuit. How are you going to do that? You won't be able to use LM317. So what you do, you use 98 volt or 95 volt Zener diode, or 100 volt Zener diode, and because you have many different voltages of Zener diodes, and you can use this circuit to provide regulation into your system. And this one obviously has some form of feedback, so it will stabilize the circuit, and you get much better, as you saw, you get much better performance than just a single pass transistor there. You can, just like how LM317 is a variable voltage regulator, you can use these circuits. Obviously you're going to need a different circuit than this, but you will be able to vary the voltage obviously over here. So you would need a potentiometer and a few other different circuitry to make it work, but you can make a Zener diode based voltage regulator variable. Back in the days, in the lab power supplies, they used to have Zener diodes, and obviously Zener diode and the potentiometer and different circuitry over here, and you have a lab power supply. That's why most of the lab power supply in the olden days will only go to 1 volt or 1.5 or 2 volt. They won't go to 0 volt because of the Zener diode that they had inside. Same goes for your LM317. It won't go below 1.25 because of its voltage reference until you introduce a negative rail, and you offset that 1.25 with a negative 1.25, and the LM317 can go into 0 volt. So as these circuits as well. And you can, as I said before, you can use these in a negative rail. Obviously you will flip things around and you have a different circuit, but you can use Zener diode into negative rails as well. And yeah, these are good to learn. These are good to know that you have alternative to LM317. You should always remember that there are alternative to LM317 and the 78 voltage regulators, because sometimes your projects ask for it. You need a 50 volt, 60 volt, 70 volt, 80, I don't know, God knows, 200 volt voltage regulators. If you need, you can easily make with this kind of circuit. Obviously you change your transistors around to make sure that they're high voltage transistors, but you can always make whatever voltage regulator you want out of a Zener diode and few transistors and other passives. And you can play around with these and make it even better performance than what we have here. This was just a basic circuit. You can tweak this around, use different values, different put capacitor in different places, and trying to kill this ripple as much as you can. and you can provide a higher current. You can cascade your pass element at the very end and provide much more current. This might provide 1 amp. You can go up to 5, 10, 20, whatever your circuit needs. You just use many different pass elements at the end, and you can achieve that. Same goes for LM317. You can use put the pass element in parallel with this, and the LM317 will do whatever it does, and it will regulate those pass transistors, and you will see that you can increase the current capabilities of your LM317 into many amps with using pass transistors at the end. I hope you enjoyed this. I didn't go into too much detail and too much parameters of these circuits. This was just meant to be a quick video for you to see that you do have alternatives to LM317. If your voltage is higher than what these little bad boys can handle, you can use these circuits to power your projects and stuff like that. And I hope this this was a good video for you guys to learn and to see that yep, there are alternatives to these bad boys. I hope you enjoyed this video. If you did, please give a thumbs up and consider subscribing, because that helps the channel grow and helps me provide more information and do more videos for you guys. And until next day, have a good day.